Hello, Dr.cisse covering anatomy and physiology. Today we'll talk about the spinal cord. Let's do a little review. The spinal cord is part of the nervous system. The nervous system is one of the 11 organ systems in the human body. The nervous system is divided into two parts: the central nervous system and the peripheral nervous system. The central nervous system is made of the brain and spinal cord, and the peripheral nervous system is made of the nerves that come out of the brain and come out of the spinal cord. If a nerve comes out of the brain, we call it cranial nerve. We have 12 of those. If it comes out of the spinal cord, we call it spinal nerve, and we have 31 of those. On the left, you see spinal cord. On the right, you see the transverse cut of the spinal cord. The questions are, what is the structure of the spinal cord? What is the function? What are meninges? What is the great white matter? What is the ascending and descending tract or spinal injury? First, let's talk about the spinal cord sections. We have different sections, just like we have in a vertebral column. Cervical vertebrae, thoracic vertebrae, lumbar, all that. It's the same thing here. We have cervical section, thoracic, lumbar, sacral. And then you see at the bottom here, you see some thin nerves coming down and a very thin in the middle called the terminal filum. At the bottom, you see the cauda equina, which is the end of the spinal cord, when there's no nerves coming out, but everything is coming down. Because the nerves coming down to your leg will come from the top here. At the top here, you can see two enlargements, cervical and lumbar. Why? Because the nerve that will serve your arm and legs have to cluster here to come down to serve both, because they have a lot of nerves coming to your legs and to your arms. What is the function of the spinal cord? Conduction. If you think about it, the information that we receive have to go through our spinal cord to get to our brain. And the brain has to give a command to come down to the organ. That is done through the spinal cord. That's why we say conduction. What about neural integration? When the information goes up the spinal cord to the brain or to the spinal cord itself, it has to be processed. The spinal cord has to make sense out of it to give a proper response. For example, when we're walking, locomotion, our spinal cord has a specific machine that will give a specific pattern to our walking so it can be smooth. And reflexes. Involuntary response to stimulus is done through the spinal cord when it's life-threatening. It means that when you touch something hot or something like that, your spinal cord will make a decision to remove your hand as soon as possible before you can even make sense out of it, because you can think about it. Those are called reflexes. Let's talk about the spinal cord. It is covered by 3 layers: pia mater, arachnoid mater, and dura mater, PAD. These are the layers called meninges. That's why when somebody has the infection of these layers, we call that meningitis. The gray matter and white matter. If you look at this picture, you can see a gray area in the middle that looks like an H or a butterfly. That's called gray matter, surrounded by a white area called the white matter. The white matter is made of myelinated axon. It means the axon terminals of neurons covered by myelin. And the gray matter is made of the cell bodies of those axons. So the gray matter has 3 horns: the posterior horn, the lateral horn, the interior horn. You can see them here on the thing that looks like a butterfly or an H. And the white matter has 3 columns. The back part is called the posterior column. The one on the side, lateral column. The one interior called interior column. So if you think about it, the gray matter has horns and the white matter has columns. Posterior horn, posterior column. Lateral horn, lateral column. Anterior horn, anterior column. What happens in the gray matter? It is the site of information processing. Why? Because you have a lot of cell bodies here that need to make sense out of stuff. Think about it. If you look at this fiber here on the posterior side, it has axon terminal that will come and synapse that connect to the next neuron. These cell bodies here, neuron, of course, they make the gray matter gray, At the same time, they have to process the information to give the command back. What about the white matter? The white matter, because it's made of the axon terminal of the neurons whose cell bodies are located in the gray matter, or some of them are in outside coming in here, the fiber here. Their job is for conduction. So the white matter will has columns that are divided into tract, right? Tract road that will take information up and down from the brain down to the organs. This is the transverse cut of the spinal cord. You can see the gray matter looks like an H or butterfly, the white matter rounded, and then you see the posterior, you know it's posterior because you see the spinous process of the vertebra here, and then you see the posterior side has a little bump here called the posterior root ganglia. It has cell bodies of sensory neurons that will come to synapse to connect to the cell body of motor neurons or interneurons here to give a command back to the motor neuron. And when the two comes together, they'll meet here to become a nerve. So the axons of the two roots form the spinal nerve. So the sensory neuron here coming in and the motor neuron coming out, when the two come together, their name is called what? Spinal nerve. You see sensory, so that means the dorsal root takes information in, process here in the gray matter, and the command is given through the ventral or interior root coming out, and the two together become what? The spinal nerve. Now you know the connection, the relationship between neuron and nerve. Neuron axons become the nerve. Neuron cell bodies or nuclei in the central nervous system or ganglia outside in the peripheral nervous system. Now, why we didn't talk about the spinal cord? We said it's information highway. It means it takes information down and going up. It's the same thing as talking about going to New York. You're traveling from south to north. If you're going up north in the nervous system, we say ascending tract. And when you stop at different cities, when you travel, for example, right? At every stop, it's like switching cars. You stop in one car, a bus, you take the switch bus or train or something like that. In the nervous system, the same thing. Neurons do not go from your outside of your body directly to your brain. They kind of synapse. That means they connect with the second neuron, talk to the second neuron, the third neuron. We call them first stop, second stop, or in biology, it will be first order neuron, second order neuron, third order neuron. But the name of the road here, you can see that, for example, the road we might call 85 North, it could be Gracile. It's just the name of the pathway you take to different area of the spinal cord. 75 North, cuneate. Then the rest of the name will be like spinothalamic. Just say New York, Atlanta, New York, Atlanta, Washington, Atlanta, New Jersey, something like that. The first name will be where it's coming from, the last name where it's going. Spinothalamic, from the spine, from the spinal cord to the thalamus, which is part of the brain. Spinoreticular, from the spinal cord to the reticular formation, which is part of the brain. Spinocerebellar, from the spinal cord to the cerebellum, so which is part of the brain. So all that is just to show you that the spinal cord job is to connect your body to your brain. It has to take a route, pathway. We call them tract. We have tract going up, giving information, and tract coming down, giving the command, telling the body what to do. So those, we have two types of neurons, upper motor neuron and neuromotor neuron. It means they stop twice. One neuron talks to the next one talks to the next one. So you see from the New York, Atlanta, DC, Atlanta, New Jersey, Atlanta, coming from there. So it'll be tectospinal, so first from the tectum to the spinal cord. Reticular spinal, from the reticular formation to the spinal cord. Vestibulospinal, from vestibular nuclei to the spinal cord. It's just to tell you that different information will go up and down. The name of the tract is just the name of the beginning and the end of the information. So let's talk about these tracts very quick. So we call them ascending and descending tract. Ascending tract do what? They carry sensory information. That means what you feel is coming up. And then when the brain makes sense out of them, it gives a command to come down to the organ to tell them what to do. Now, during that time, they don't come straight directly. Sometimes they decussate. What is a decussation? they cross over to the next side. That's why sometimes when you have people having stroke, the left side of the brain control the right side, and the left side, the right side control the left side, because those tracts kind of cross over, they decussate, cross over, so that one part of your body is controlled by the other part of your brain. That's why it could be ipsilateral or contralateral. So ipsilateral will be on the same side, contralateral will be in different side. Let's look at the ascending and descending tract. If you look at this one, for example, the red one on the left is ascending. The posterior column, we know that already on the back, has 2 fasciculi. So fasciculus just means the tract, right? Gracile, which is like 85, cuneate 75 north, basically going north. It's just a tract where you have information going there. Then you have a spinocerebellar. It can tell you it's come from the spinal cord to the cerebellum, or anterolateral spinothalamic, from the spinal cord to the thalamus. Then the descending tract, you can see that cortico-spinal tract, from the cortex of the brain to the spinal cord. For example, reticulospinal, from the reticular formation to the spinal cord. All these are part of the brain we'll talk about in the next lecture. To tell you what part of the brain is coming to, what kind of brain is coming from. If information is going up, it's called ascending. If it's coming down, it's called descending. So let's talk about ascending. In the ascending, we have first order, second order, and third order neurons. Why? Because the neurons do not go directly from one spot to the brain. It kind of stops talking to the next one talking to the next one. So that's why we call them first order, second order, and third order. Now the gracile 85, cuneate 75 fasciculi, just like the tract, what do they take to your brain? Vibration, visceral pain, like your stomach is hurting, deep and discriminative touch, when you touch somebody hard and they can feel the difference between the two positions. Proprioception from lower limb and lower trunk. What is proprioception? Or from upper limb, depending on the fasciculi. What is proprioception? Is the feeling of the position of your body organ. Proprioception means if I put my hand behind my head, I know where it is. In my mind, I kind of can tell. So the spinothalamic tract will take tickling. You have a question in our exam, say when somebody tickles you. So the spinothalamic tract take pain, tickle, pressure, temperature to the brain, or even itch. Something is itchy. Or spinoreticular tract, from the spine to the reticular formation, the pain from injury. When you get hurt, that pain is spinoreticular. Then you see here the ascending tract again. So I'm just showing you the spinothalamic, spinoreticular. You can stop the video and watch this for a little while so you can learn the different tract. Ascending tract. Why it's called ascending? Is going up. What is it taking up? Information. Gracile and cuneate. What do? They take vibration, visceral pain, discrimination, and proprioception. Gracile and cuneate, I just call them 85, 75 north. What do they take? Pain and pressure and stuff like that. What about the spinothalamic tract? Tickling, temperature, pressure, taking up to your brain. What about spinoreticular tract? Where does it end? In the cerebral cortex. This one has even fourth order neuron. This one, you kind of feel the pain. You know it. That's why it gets to the cerebral cortex, telling you that you know what's going on. You're conscious of it. Because when you have pain, you know it's hurting. So that's why you have a fourth order neuron that takes you up to the cerebral cortex that makes you allow conscious of the pain. What about the spinocerebellar, muscle and tendon? And then it ends with at the cerebellum. What about the descending tract? Descending tract gives the command. Motor neuron. What does that mean? Makes you do something. So the upper motor neuron is the first one that comes from your brain down. And the lower motor neuron will be the one going to the organ, ending up at the specific organ needs to do the job, which will be, for example, to your muscle or other target organs. Look at the descending. Look at it coming 85 south and 75 south. It comes down to give a command to carry something specific. One of the example, tectospinal tract. It begins where in the midbrain, a region called the tectum, right? Reflex turning of a head in response to sight and sound. When you hear something loud, you just jump and look. because of this descending, because your brain tells you to look there, like a reflex. Reticular spinal tract, regulation of awareness of pain. So this one kind of tells you if it's hurting or not. So this is going to be descending tract, telling you what to do and how to do it. Example of destroying motor neurons, for example. Remember we said sensory neurons make you feel, motor neuron makes you do something. So destroying motor neuron kind of stops you from using your muscle. One of the example, ALS is a disease that destroy motor neuron. Why? Because it affects the myelin covering of the motor neuron. The myelin sheath cannot cover them. So the motor neuron cannot work, which stops you from using your muscle. Spinal cord trauma. What is paraplegia? Paralysis of both lower limbs. Quadriplegia, paralysis of all four limbs. Hemiplegia, paralysis of one side of the body. And paresis, partial paralysis or weakness of the limb. So to conclude, what is the structure of the spinal cord? We need to know it has section. What is the function? Communication, taking information up and down. Information up, command down. What are the meninges? The pad, pia, arachnoid, dura, right? Meninges just a layer. Gray matter is what? The gray matter is the cell bodies of the neuron, and the white matter, axon terminal. As ascending tract, taking information up, descending tract, giving command down. Spinal injury, when you cut the spinal cord, everything below will be paralyzed. Everything up will not be affected. I hope this is going to be very, very helpful for our class next week. Thank you very much for watching. I'll see you in class.